Good day, students. I am Sir Flor, and this is Learn High School Mathematics with Sir Flor. Our topic for today is about the circle. This is grade 10 mathematics. So, without further ado, let's get started. Our objectives here is at the end of the lesson, you are expected to number one, define and describe terminologies involving circle, illustrate the secants, tangents, segments, and sectors of a circle, and derive deductively the relations between the chords and the radii, and solve problems involving circles. Here are the basics on circles or the terminologies on circles. Here's the figure on your left side of the screen. This is known as the circle. Let us define what is circle. This is a two-dimensional shape formed by the set of all points which are at the same distance from a given point on a plane. So meaning to say that in this circle, for example, if you have a given point on a circle, and when you have to connect this on the center of the circle. And there is another point here, let's say on this one, okay? So I will show you this one. So let's say this is your point here somewhere on the circle and another point here on the circle. And whenever you connect here from this point on the circle and to the center, and of course another point here on the on the circle to the center of this circle, these two lines or these two line segments having their equal measurement, or they have their equal measurement. So this one is known as the circle. So this one having the same distance. And this circle can be easily constructed by drawing a curve that is have the same distance from a central point known as the center. So remember, this point here is known as the center. Then whenever you draw a line segment starting from this point to the to this point, which is the center, and the other point here, which is on the center of the circle, meaning that these two line segments having their same distance. Let's say we have a circle O and we have point B here that is connected to the center of the circle, which is point O. Let's have the point of the circle point B. This line segment OB is known as the radius, or the plural of this one is radii. So what is the definition of radius? When you say radius, it is a line segment connecting from the center of the circle to one of the points on the circle. And whenever you extend this one, as you can see, there is another point. There's a line segment, which is a line segment CB that is passing through the center of the circle. And this one is known as the diameter. When you say diameter, this is a line segment that passes through the center of the circle and their endpoints lie on the circle. What is the difference between this from the diameter to this one? So if you observe this illustration, CB is now on this CB is known as the chord. When you say chord, this is a line segment that will not pass through the center of the circle and their endpoints lie on the circle. So meaning to say that the difference between this one and the diameter is that in diameter, a line segment that is passing through the center. But in chord, this is the line segment that is not pass or does not pass through. Meaning hindi po hindi po magpapass through o hindi po dadaan yung line segment na yon sa mismong center ng circle, which is yung point O. I hope that you get the difference of diameter and this one, the chord. So what is the difference between the circumference and the area of the circle? So when you say circumference of the circle, this is the total distance around the circle. So meaning to say, this para siyang perimeter actually. Pero kasi this involves circles, so circle lang talaga siya. So parang perimeter ng or the total distance around the circle or the perimeter around the circle. When you say area of the circle, this is the total measure of space bounded by the circumference. Okay? Yung space, ibig sabihin yung the number per square unit sa loob ng circle. That is bounded by the circumference. And the formula for the circumference here is C is equal to pi times D or C is equal to 2 pi R. Okay? So remember that the pi there has its equivalent value. Okay? And of course, the formula for the area of the circle here is A is equal to pi R squared. And please do note that we have to use the pi, which is 3.14 always. Okay, whenever you compute for the area or circumference of the circle, you have to use pi is equal to 3.14. Let's have an example. Find the circumference of the circle whose diameter is 15 centimeters. So let's say this is a figure. So how will you find the circumference of the circle whose diameter is 15 centimeters? So the solution for this one here is what formula should we use for this one? So the formula that we'll be using here is the circumference is equal to pi times d. Remember that the pi is equivalent to 3.14. And whenever you solve this one, 3.14 times 15, this is 47.1 centimeters. Do not forget the unit of measure. This is very important. I hope that you get it. Next example. Find the circumference of the circle whose radius is 6 centimeters. So this is the figure. So before I reveal the answer, pause this video. And when you're ready, kindly resume this video. Done already? So what's your solution? So our solution here is C is equal to 2 pi R. Okay? So we have here C is equal to 2 times 3.14 times 6. And 2 times 3.14 times 6 here is 37.68 centimeters. If you get this correct, then you are a genius. So do not forget, whenever you compute this, you have to use the calculator. Next example. Let's say determine the area of the circle whose radius of 11 meters. So we are finding for the area of the circle. So we have here a diagram of 11 meters. So for the solution, we have to use always area is equal to pi r squared. And this one will be pi will be converted into 3.14. So the area is 3.14 times 11 squared, which is equivalent, which is 3.14 times 121 is 379.94 squared meters. Try this on your own for this next example. What is the area of the circle if the diameter is 14 meters? So this is the 14 meters. Please think first before you go to the final answer. because this one is much crucial, or this is confusing for you. Pause this video to try this. And then and then when you're ready, please resume this video. Done already? So let's see your answer. So our solution here is a is equal to pi r squared. And remember, a is equal to 3.14 times 7 squared. Why is it 7? Because r there is a radius. So remember that the radius is half of the diameter. Meaning you have to get the radius, since the diameter is given, you have to divide 14 by 2 so that we get 7 as our radius. So therefore, A is equal to 3.14 times 7 squared. And whenever you compute this, 3.14 times 49, this is 153.86 squared meters. I hope that you get this one. Let's have the next one. Okay, let's have continuation of our terminologies, or the basics of circles. Next one, we have the congruent circles. When you say congruent circles, as you can see on this figure on your left, they have we have two circles with the radii AB, and the other one is FG. So when you say congruent circles, they are distinct circles having the same measures of radii. So meaning to say that if AB is the measure of AB is equal to FG, or the line segment FG, therefore these two circles are congruent to each other. Another term where we have concentric circles. So as you can see in the figure, there is a big circle and there is a small circle. And we have two different radii that shares the common center. So when we say concentric circles, these are the circles in the same plane having the same center. Another terminology, we have the secant. So let's say we have a given circle. We have the circle C with the center, of course, the C. And we have here a line with 2 points A and B. So what do you mean by secant? When we say secant, this is a line that intersects the circle at 2 points. Next, we have the tangent. Let's say this is another circle, same with point with the center C, and we have here a line outside the circle with naming this line M, and we have a point here which is point B. So line M is known as the tangent. What do you mean by tangent? Tangent is a line that intersects the circle at exactly one point, called the point of tangency. Remember that the point B there is known as the point of tangency. Let's have this figure again. We have circle O with the center point O, and we have here 2 points AB. So let's have the definition of an arc. When you say an arc, this is this is the arc AB. Okay? And the true definition of arc here is the part of the circle named by its endpoints. Okay? As you could say on the red part, this is called the arc. And not only on the red ones that you've seen there, but also we will consider the blue one, the blue arc here on the other one. So this one is also known as arc. Let's say this one. So this figure is known as the semicircle. What do you mean by semicircle? When you say semicircle, this is an arc that measures exactly 180 degrees. So as you can see, the line segment AB is a diameter. And if you see that this is a diameter, therefore, the arc AB there is known as the semicircle. That's of another term. I have a point C somewhere there, and let's say this there is a indication of the arc A, which is arc AC, and this arc AC known as the minor arc. When you say minor arc, this is an arc that is smaller than semicircle or measures less than 180 degrees. Okay, so therefore, so this one, not therefore. So as you can see, AB again is a diameter. And remember that a semicircle is equal to 180. But if it is less than 180, this is known as the minor arc. And the other one is known as the major arc. What is the major arc? If in a while ago, minor arc measures less than 180. Major arc is also an arc that measures greater than the semicircle or greater than 180 degrees. Okay, let's go over to the sector of the circle. When you say sector of the circle, this is a region bounded by an arc and two radii of the circle. So let us have here a figure with point O as your center of the circle. And we have 2 points here, point C and point B lie on the circle. And we will be giving you we will be two line segments that form an angle. So on the yellow ones are known to be the sector of the circle. Remember, when you say sector, the region that is bounded only by an arc and two radii of the circle. And of course, the segment of the circle. When you say segment of the circle, this is a region bounded by an arc and the segment joining the endpoints. So as you can see on the next figure, this is a sector. But when you say segment of the circle, this is the one. So as you can see, there is an arc, which is arc CB, and there is a line segment CB here. So the region bounded from this arc CB and the line segment CB is known as the segment of the circle. Here are some theorems regarding this part. Let's have theorem number 1. If the radius of the circle is perpendicular to a chord, then the radius bisects the chord. So as you can see on the figure on your right, on your left, I mean, this is the circle O, and let's say DO is your radius, or line segment DO is a radius and line segment AB is your chord. Now if these two line segments, which is the radius and the chord, bisect to each other, meaning when you say bisect, this is or this is a line segment that cuts another line segment, a line or an angle into two equal parts. Okay? So if they bisect to each other, meaning the line segment AC and CB are congruent to each other. Let's go to theorem number 2. If the radius of the circle bisects the chord that is not a diameter, then the radius is perpendicular to a chord. So this is converse of theorem number 1. So again, If you have radius, if the radius AB is bisects a chord which is DO, then the radius is perpendicular to the chord, or AB or chord AB is perpendicular to chord DO. I hope that you get this. So if you remember again, the the theorem that you will be used on your last grade 9, which is the Pythagorean theorem. What does Pythagorean theorem says? That in a right triangle, the square of hypotenuse is equal to the sum of the squares of the legs. So the formula for the Pythagorean theorem is c squared is equal to a squared plus b squared. So you have to use that one to solve um, for the following regarding this theorem. First example, if the length of the radius is 7 and CO is 3, what is the length of AB? So, whenever you solve this problem, here is what we are going to do. So, remember that the radius is 7. So, it's either BO or AO is 7. So, this radius is 7. This one is also 7. And DO is also 7. So, this one is also 7. Remember, why is it all 7 here? Because the radii of the given circle are all congruent, or they have the same measurement. Okay? And remember that the CO here is 3. So this one is 3. So how will you find the length of AB? So which is 2. Okay? So what we're going to do? So remember that we cannot find AB if you can't find the line segment AC first. So we need to find out first the line segment AC, which is here on this question mark, before we find the value of AB. So we have to use the Pythagorean theorem. So the Pythagorean theorem again is C squared is equal to A squared plus B squared. But this time we will be using another letter or the notations of the line segment. So let's say this is AO. So you can use AO or OB. It's okay. But we have to refer first the AO first. Okay. So AO here is 7. Okay. So therefore AO squared is equal to A squared is let's say OC squared plus AC squared. Okay. So AO squared here is 7 squared equals OC, which is 3 squared plus AC squared. 7 squared is 49 equals 3 squared is 9 plus AC squared. 49, then you have to transpose the 9 to the other side. So therefore 49 minus 9 is, this is minus 9 actually. So 49 minus 9 here is 40. 40 is equal to AC squared. But since I want AC only, so what we're going to do is to get the square root both sides of the equation. So therefore AC here is square root of 40 or 2 square root of 10. Since we are having AB, which is twice of this one, so therefore AB is equal to twice of AC. No, no, no. AC and AC plus CB. Okay. So AC plus CB. And remember, AC is equal to CB. Okay. So therefore, we have AB here is 2 square root of 10 plus 2 square root of 10, which is AB here, is 4 square root of 10. So this is your final answer. Did you get it? So let's have another example. In the figure on the left, DO bisects chord AB at point C. If AB is 16 and CO is 6, what is the length of the radius of the circle? Pause this video and try it on your own. If you're ready, please resume this video. Done already? Let's have this part. So in the figure on the left again, DO bisects a chord AB at point C. Let's say if AB is 16, this one, AB is 16. Okay, this is 16 and CO is 6. How will you find the radius of the circle? So I want to find this one. Okay, so remember that to find the AC here, since you are only given AB, but you have to find the AC. So the value of AC here is 8. Why is it 8? Because half of this one, half of 16, or half of AB is AC and also the CB itself. So 16 divided by 2, your AC here is 8. And remember, you have to use the Pythagorean theorem. C squared is equal to A squared plus B squared. So C squared here is, which is AB squared, which is AC, I mean, square, AC squared plus AC squared plus CO squared is equal to AO squared. Okay? Or you can interchange that. Okay? So therefore, AO squared is equal to 8 squared plus 6 squared. 8 squared here is 64. 6 squared is 36. And 64 plus 36 here is equal to 100. And I want AO only, so therefore square root both sides of the equation, so therefore AO is equal to 10. So the length of the radius is 10. Did you get it? If you get that, if you get this correctly, then you're great. You're great. Great job to you. Next theorem. In congruent circles, if two chords are the same distance from the center, then they are congruent. So remember, if these two chords of the same distance from the center of the circle, so meaning to say that uh, CD and HJ here in congruent circles, if they have the same distance from the center, which is point F and point B, therefore they are congruent to each other. Okay? And lastly, theorem number 4. If two chords are equidistant from the center of the circle, then two chords are congruent. Meaning to say that if these two chords are having equal distance from the center of the circle, then we can say that these two chords are congruent to each other. When we say equidistant, again, equal distance. Let's have the final example. Given the figure on the left, if AB is 2x plus 7 and CD is 35, find the value of x. So according again to theorem number 4, if these two chords having equal distance from the center of the circle, then we can say that these two chords are congruent to each other. So if they are congruent to each other, therefore, we can have the equation AB is equal to, let's say you have C here, is CD. Okay? AB here is 2x plus 7 is equal to 35. And then you have to transpose the other side. So therefore, 2x here is 35 minus 7, which is 22, I think. Okay? 22. Or 20, not 22, but 28. Okay? 28. Then divide both sides by 2. Correct me if I'm wrong. Okay? So divided by 2, so therefore x, no. X is equal to what? 28 divided by 2 is 14. So the value of x only here is 14. I hope that you get this one. Kapag medyo malabo po ang iba pong mga parts dito, you can uh, review again. Pwede nyong slide ulit pabalik yung mismong nandun sa red part na yun. Or hanapin nyo ulit yung part na medyo naguluhan kayo. If you have any questions, you can leave on the comments or leave a comment below. And I will answer to your questions. And that's it for today. I am Sir Flor, and this is Learn High School Mathematics with Sir Flor. Have a great day, everyone.